Okay, so this is number 1 in the closure. And it says to graph this inequality right here. So first we need to graph the boundary line, which means we're just going to make this an equal sign for now and just figure out what our boundary should look like. And actually, we should probably decide like what shape this is going to be, whether it's going to be like a line or a parabola. Because it's got x squared in it, we know it's going to be a parabola when we graph it. So since we know it's a parabola, first thing we want to figure out is where the x-intercepts are going to be. So whenever we want to find x-intercepts, we are going to make y 0 and then solve for x. So in order to solve this, I could do any of the 3 methods. Like I could do factoring, completing the square, quadratic formula. Factoring is usually the easiest one if it's something that is factorable. So I can try that and see. So I'm going to do my generic rectangle and my diamond. And then put everything where it goes. So it looks like I need to find 2 terms that multiply to be negative 30x squared and add up to positive 1x. So if they're going to multiply to be a negative, I know it's going to have to be like a positive and a negative number, and they have to add up to positive 1. So basically they need to be numbers that are like only 1 apart from each other, but 1 positive, 1 negative. So things that multiply to be 30, if you're not sure, you could just start making a list. Like 1 goes into 30. 30 divided by 1 is 30. 2 goes into 30. 30 divided by 2 is 15. 3 goes into 30. 4 does not. 5 does. And those 2 will work out because they're just 1 apart, so we can make them add up to positive 1 by making one of them negative. So if we make the 5 negative, the 6 positive, then that'll work. And then we're going to put those in here and then figure out our outside factors. So my factors end up being x plus 6 and x minus 5. So that equals 0 because it was equal to 0 up here. And then at that point, I'm going to set each factor equal to 0 and solve to get my x-intercepts. And when I do that, I'm going to get an x-intercept at negative 6 and the other one at positive 5. So I'm going to mark those on the graph. One at negative 6 and one at positive 5. Okay, so I have x-intercepts. A lot of times it's also helpful to use the y-intercept when we're graphing. So to get y-intercept, we make x 0. So if I do that, if I take this inequality and plug in 0 for both x's, I get negative 30. So that tells me where my y-intercept is. So it's going to be right here at negative 30. And I could also find my vertex to just give me a little bit of a better graph. So to do that, I have to find the x value that's in the middle of my 2 x-intercepts, and I can do that by finding the average of those. And to find the average of 2 numbers, you add them together and then divide by 2. So if I do that, negative 6 plus 5 is negative 1, divided by 2 is negative 1/2. So this is like negative 1 right here. So this would be like negative 1/2. So that's going to be like my line of symmetry for my parabola. And the vertex is going to have an x-coordinate of negative 1/2. And then if I plug in negative 1/2 for x, that will give me the y-coordinate. And I think I'm going to use my calculator to do that part. So each time that I plug in negative 1/2, I am going to put parentheses around it wherever there's an x. So negative 1/2 squared plus negative 1/2 minus 30. So my y value for my vertex is negative 30.25. So it's just a little bit lower than my y-intercept. So kind of like right there. And then I can sketch in my parabola. Since this isn't equal to, it's just less than, I need to make it a dashed parabola to show that the points right on the parabola are not part of the solution region. Just like we would make it a dashed line, you do a dashed parabola. And then this says y is less than. So whenever it says y is less than, that means we are going to shade below. And so I'm going to shade it and everything below my parabola. So if I like start and put my pen on a point on the parabola and go below that, this is the area I want to shade. The parabola is my boundary. So I'm going to shade everything up until I hit the parabola. So my shading should look like that.